This is Dr. Wysong. This series of videos on the big questions of life will show where each one of us is led if we dare to leave behind preconceived ideas and see where reason and evidence lead.
The laws of chemistry. For life to arise spontaneously out of just a simple brew of atoms, as evolution demands, basic building blocks such as amino acids, which are precursors to proteins and enzymes, sugars, which are precursors to carbohydrates, glycerol and fatty acids, which are precursors to fats, and nucleotides, which are precursors to DNA and RNA, must first form. For those readers unfamiliar with chemistry, what I'm about to get into now may be a little bit difficult to understand. And I've tried to simplify it as much as possible so the main points can be easily accessed. The laws of chemistry demonstrate yet another reason, though, that those who believe life can emerge spontaneously from matter cannot provide any proof or even a feasible step-by-step mechanism. Let's start with amino acids and proteins. Chains of amino acids form proteins that comprise enzymes, the catalysts that drive the biochemical and metabolic machinery of life. All the components of life could be present, but without enzymes nothing further would happen other than second law degradation. That is, proteins reverting to amino acids reverting to random atoms, the exact opposite direction evolution demands. Spontaneous evolutionary protein formation violates the laws of chemistry. Number 1. Chemicals that comprise amino acids, carbon, nitrogen, hydrogen, oxygen, sulfur, can form millions of molecules other than amino acids. So out of this soup of potential molecular products, evolution demands that amino acids segregated in order to link up to form proteins. The probability of that happening is beyond the universal probability bound of one chance in 1 followed by 150 zeros, as discussed in the previous parts. In other words, it would be impossible. Number 2, amino acids can exist in either right or left-handed forms called D and L enantiomers. They are mirror images of each other. They contain the same atoms and are arranged the same, but they are mirror images and thus not exactly alike. Approximately a 50-50 mix forms in laboratory amino acid synthesis. That's also what would have occurred, if it ever really did occur, in the little broths nestled on the lightning-scorched volcanic landscape at the dawn of proposed evolutionary prehistory. But life's proteins are not composed of a mixture of D, dextro, and L, levo amino acid enantiomers. They are almost exclusively left-handed, that is, levo, the L form. Evolution's random chemistry just simply cannot account for this. 3. Proteins are not just straight strings of amino acids. They have a secondary, tertiary, and quaternary structure that arises as the string twists and folds upon itself to create a three-dimensional form. This folded globular-like structure is critical to function. Once the primary amino acid strings are formed, which is a virtual impossibility, as you'll see, then a biologically viable protein takes on a mind of its own and proceeds to rapidly fold into a three-dimensional shape in a matter of seconds or minutes. This folded structure is critical because it exposes reactive sites in specific positions on the surface to permit specific biological and catalytic functions. Even a tiny protein of 100 amino acids has potentially trillions of folded forms, but only one shape will do in living organisms. That's called the Leventhal paradox and does not accord with evolutionists' random chemistry. The importance of folded protein shape is highlighted by prion diseases, such as transmissible spongiform encephalopathies, including mad cow disease, sheep scrapie, chronic wasting disease in deer, Creutzfeldt-Jakob disease, and perhaps Alzheimer's, dementia, Parkinson's, and other neurodegenerative conditions. Prions are normal brain proteins, but when they simply fold wrong, devastating disease results. Sickle cell anemia occurs when only 2 out of the 574 amino acids in the blood's oxygen-carrying hemoglobin molecule are wrong. Each red blood cell contains about 280 million molecules of hemoglobin, and this defect causes the red blood cells to distort and even rupture, and death can result. There are hundreds of thousands of proteins and other sequence molecules of specific structure and shape in every cell. Things have to be perfect for health to proceed. Evolution's random chemistry is totally incapable of accounting for such perfection. Also, this is number 4, also consider that an enzyme could go through all the work of assembling its chain of L amino acids, fold in a precise 3-dimensional way, and then be scuttled if the temperature ever rises above 118 degrees Fahrenheit. And that is a highly likely scenario on the early molten Earth and in the evolutionist ancient steaming volcanic soups. Number 5. Before enzymes come to that inglorious end, their precursors don't know how to assemble and fold without pre-existent DNA. Not only do enzymes need DNA, DNA cannot form without enzymes. Both must exist at the same time in order for either to exist. It's a chemical version of the which came first, the chicken or the egg conundrum. Evolutionists imagine each one developing step by step on their own and in synchrony, without ever laying out the step-by-step chemistry or explaining how one could occur without the other. If the components of DNA were present in the same brew as the amino acids, this is number 6, if that were to occur, the toxic combinations would result. For example, the ribose needed in DNA is a reducing sugar. It will combine with the amino acids in a Maillard reaction. The resulting advanced glycation end products, AGEs as they're called, are toxic to every cell in the body. They can be a factor in aging and degenerative diseases such as diabetes, atherosclerosis, chronic kidney disease, and Alzheimer's. Every time you cook a meal, you're creating these noxious chemicals. Such toxins cannot create the path to life. For about the past 40 years, I've researched nutrition, food chemistry, and processing to try to create the healthiest nutritional products possible. Glycation, mentioned in Part 15, is just one of the numerous factors that stand in the way when combining various nutritional elements. Food scientists cannot overcome these problems, so how on earth could the noxious combinations be avoided in the random evolutionary brews? They simply couldn't. Water problems. You've probably heard that since our body fluids are similar to seawater, we must have come from the sea. Well, that's a nice story, but when scientists try to make the biochemicals of life in seawater, nothing happens. This is, in part, because of the law of mass action. In a chemical reaction, there are starting ingredients and end products. Most biochemical reactions can go either way, toward the end products or back toward the starting materials. The direction the reaction takes depends upon the relative amounts, the mass, of the materials on each side of the chemical reaction. The more ingredients, the more pressure to form products. The more products, the more pressure to revert back to the left to the ingredients. Many of the chemical reactions that form life's biochemicals are condensation reactions. That means ingredients combine and form water as one of the products. For example, if you look in the written text of this, you'll see how the reaction looks if proteins were to be formed in the ocean. You'll see an amino acid plus an amino acid forms a protein plus water. Note that water would be the predominant component in an early Earth milieu consisting of the ocean primarily. That means, according to the law of mass action, the reaction would not go to the right toward the formation of proteins, but to the left toward their disassembly into the starting amino acids. The only reason the reactions go to the right inside a watery living organism, which is about 70% water, is because enzymes drive the reactions to the right. But there were no enzymes back in the primordial sea, because enzymes are proteins and cannot form in the sea because of the law of mass action. Further insult to evolutionary injury is the fact that many amino acids are subject to degradation by heat, light, and oxidation. Thus, the ingredients for proteins and enzymes would be foiled before they even had a chance to try a doomed condensation reaction. Lipids. Lipids are a class of compounds that includes fats, sterols, and oils. They're important to life because virtually every biological membrane is made of a sandwich of these molecules called the bilipid membrane. They're also essential in forming hormones from cholesterol primarily, and cell, tissue, and immune regulators called eicosanoids. Although the popular press and brochures in your doctor's office promulgate propaganda about bad fats and cholesterol, lipids are actually critical to life, that is, in their natural, unaltered state. For life to form, lipids had to form. But due to the fact that they form via condensation reactions, lipids would not form in a watery milieu. They would meet the same fate as attempting to form proteins in a watery milieu. Additionally, the essential fatty acids that are so important to metabolism are highly vulnerable to oxidation. Oxidation is like biological rusting, if you will. Oxidizing minerals, heat, oxygen, acidity, and even light will not only render them useless, but convert them to free radical and trans fat toxins. If you want to learn more about this topic, see my books, Lipid Nutrition and the Cholesterol Myth. No early Earth environment can even be conceived in which these complicated, long-chain, fragile lipid molecules could arise by chance, remain biologically promising, and non-toxic. There would have been photo-oxidizing sunlight back then, and lots of oxidizing minerals. At some point, there was oxidizing oxygen, electrical discharges, and heat cooking things up. Such a noxious cauldron would never do for either forming or protecting essential fatty acids, so they could evolve. DNA. DNA is the great biochemical hope for evolution because it holds the promise of replication. However, aside from the toxic glycation mentioned above, the ribose sugars, which is the deoxyribose, the D part of DNA, that form the backbone of DNA, are of only one enantiomer, in this case the right-handed or the dextro variety. But when these sugars form outside of living tissue, they are a 50-50 mixture of DNL forms. It's the same situation we had with the amino acids. What's more, the mass action of water gets in the way of DNA synthesis, driving the condensation reactions to the left, back toward the simpler ingredients. On top of that, remember that the ribose sugars cannot form if amino acids are present. But amino acids need to be present because they form enzymes, and enzymes are necessary to join the subunits, the nucleotides, of DNA. By far the biggest evolutionary problem with DNA is its information. The DNA in a single cell contains at least the equivalent of the information in 100,000 pages of Encyclopedia Britannica. Osselton calculated that it would take a million monkeys typing for 1,000,000 years just to have a chance of typing 2 words, like Encyclopedia Britannica. To type 2 lines from one of the volumes would be even worse. It would require like a number of strokes equal to 1 followed by 150 zeros. Clearly, millions of pages of information, as found in DNA, could not arise spontaneously. This doesn't take into account the fact that functional DNA is not a bare molecule in cells. The new science of epigenetics demonstrates that proteins and other complex biochemicals shroud the helix and serve as switches to turn sections of the molecule on and off. All of the above chemical and probability and impossibilities would apply to the origin of these shrouding molecules. Dead ends are not evolution. Although heralded by evolutionists as proof of spontaneous generation, simple chemical products produced in origin of life experiments are not nascent forms of life. Any progression of chemicals to form more complex states would require incremental steps, but an event such as the formation of an amino acid has no memory. It's dead-ended. It does not know to hold its form until the next improbable event occurs to build it up into the more complex next step. Life would require the piling on of millions of functional complexities, step by step, all remembered, held, and improved upon. Such progressive functional complexity occurs nowhere in our reality, other than within already formed living organisms. Natural laws forbid the spontaneous formation of complexity, such as found in life. There are no footholds upon which one event can advance to the next. Just forbidding chemical and probability laws and a slippery thermodynamic slope where everything slides back to where it began, or less. The laws of chemistry deny evolution's very beginning and affirm intelligent intervention. Notice that this conclusion does not require any religious predisposition. We're simply letting known truths guide us.
Any evolutionist who disagrees is free to prove by evidence or experiment that complex things, on the scale of complexity found even in the simplest living organism, can arise spontaneously. But when pressed for the actual nuts and bolts of how spontaneous generation could occur, like specific step-by-step chemistry, nothing's presented other than faith, claims, and hopeful stories. That's faith-based religion, not reason or science. Thank you for listening. Keep in mind that solving the big questions requires foundations upon which truthful answers can be built. So please work through the series sequentially. This information has taken decades of research, thought, and writing. Aside from the peace of mind the solutions have brought me, the only reward I seek is hearing that it's helped you. Feel free to contact me with any comments or questions at asifThinkingMatters.com.